So you can see the body, it moves, but it doesn't really look like a fish yet. But it changes when I put it underwater.
These robotic fish almost look and feel like real fish, but they compute data while swimming in places that would be dangerous for an actual fish. In 2002, a big oil company approached this team of mechanical engineers at MIT in hopes of creating a robot that could easily move through oil wells.
We were brainstorming with them about ideas on how to maybe develop new types of devices that could be used not only for the perhaps oil wells and also for other wells that are offshore. There are some applications perhaps for reconnaissance, watching the waters, for example, from contaminations and so on.
The fish's bodies are built with polymer and silicone compounds cast in a mold.
It has a minimum number of actuators in them. Maybe the motors that you use, not maybe 10 or 20 or 100, but maybe a small amount.
And it's the build that determines just how well it can mimic a real fish's movements. But unlike real fish, these robots have wires sticking out of them.
Ultimately, mobile robots need to move on their own. They cannot be tethered. They have to carry their own power supply, so efficiency and how well you can use energy is very important.
This is because Yusuf Toumi says it makes them easier to study in lab settings.
Notice we play around a little bit with the colors. That's not only out of silliness of trying to make a cooler looking fish, but also that allows us to test different materials.
The team creates different species of fish, such as sharks, tuna, and bass.
These things are supposed to look like fish and behave like fish, so you can't tell, hopefully a mechanical or a robotic fish from a real fish when they are in the water.
Since 2002, the evolution of this aquatic creature has come pretty far.
First one started in a sink, here. So it didn't go very far and it was swimming like very wobbly.
But Mother Nature still has the upper hand.
The fastest one we've been able to build was around 1 body length per second, which is still only 30% of the speed of this particular fish at that given swimming frequency.
For Discovery News, I'm Casey D. Gardner.